Hello. Hi. Hi guys. Am I audible? Like you can type if I'm audible, you can type it on chat box. Okay. Yes. Yeah, Nivedita said yes. So am I audible to everyone? Okay, so we will wait for some more time so that your friends can also join. Okay. So after that we will start the classes. You can call your friends by the way to join the classes who haven't joined. Is the screen visible to you? Like are you able to see the screen and PPT that I have shared? Okay, good. Okay, so we'll wait for 2 more minutes so that your friends can come. Like friends can join the class and then we will start. Like last class, is there any doubt that you are having in the last class? And how is the class? Like how is the revision classes of the other subjects going? Are you joining for that also? Like is it good? Okay, so we will start our session. In the meanwhile, if your friends are not here yet, you can inform them. You can just text them or you can just call them to join the classes soon. In the meanwhile, we will start the session. Okay. So last class we have discussed what? We have discussed about motion, right? Motion was the chapter that we have discussed. We have discussed how to perceive motion or how we can actually say something is in motion that we have discussed in the last class. So today we are going to discuss about force and laws of motion. Like how it like in the last class we have discussed that how an object can move, like how can we perceive motion or how can we visualize motion. So today what we are going to learn is we will be discussing about how force is going to affect motion. Like there are different when we apply something, like if you want to move somebody we need to apply an energy, right? Apply force. So that we will be discussing today, like that we will be revising today in today's class. Okay. So first of all, I just want to ask you one thing. Like you have come across this kind of situations in your life, right? Like you might have come across this kind of door where you have to either push the door or pull the door, right? So what are you doing there? Like what exactly are you doing? You are actually means if you are trying to open something, if you are trying to, let us say for example, if you are trying to open your bedroom door, what will you do? Like you have to apply some form of like you have to apply some form of effort, right? You have to push it, either push the door or either pull the door, depending on which direction you have to apply. So basically what you are doing there is you are actually applying some form of effort known as force. Okay. So, and even we have, like, we might have got confused in this kind of situations where whether we want to pull the door or we want to push the door. So what we are doing is we are actually applying some form of effort, which in which what happens, like what happens when we are putting that effort to the door, like what is the resultant of effort? What will happen, like I'm saying you're trying to open your door, you need to push, you need to give some effort to the door. So what will be the resultant of that effort? The door gets opened, right? It means that you are applying a force and you are getting a resultant from that. Okay, so what is force is what we are going to discuss first. So what is force? Like in this situation, you can actually see one guy, you can actually see one person is trying to push something. So actually we have different kind of force. Okay, that we will discuss on the upcoming part. But here you can see that one guy is there and he's trying to push something. He is trying to put up an effort on something so that there will be some form of resultant happening, right? So what is that resultant is what we are going to check. Okay. So here actually you can see that there is a point of contact between the object and between the person. So along with this point of contact, he is applying some form of effort so that what will happen to this byproduct will be that this particular thing, this particular box which carries something, which carries a big thing, will actually move, right? So that is an effect of force that we are actually applying. So force means it's actually a push or a pull of an object in which you are able to see the screen, right? Yeah. So force basically saying that force is a push or a pull of an or pull upon an object resulting from the interaction between two objects. So this interaction between two objects is very important in terms of force. If you are analyzing or if you are analyzing something which in which force is experienced or in which force is acting upon, then there should be some form of interaction. You cannot just say that if I am having, let us say for example, I am having one object here, one, let us say one rectangular block is placed and I am standing next to it, like next to it, and I'm not having any particular form of interaction between this rectangular block and me. So does it mean that I'm applying any force? Like, can you say that I am applying? Good evening, Sridhar. So can you say in this situation, can you say that whether I am applying a force or not? Am I applying a force? You can actually type in the chat box like you did in the last class. So like I will just repeat the situation. I am having a rectangular block which is having a certain mass or certain weight and I am standing next to it, but I am not actually doing anything. So does it mean that in this particular case, am I applying any kind of force? So that is the question. Like, am I applying any kind of force in this situation? Yeah, you can clearly see that whether I am applying a force or not, right? Yeah, I'm not at all applying. Very good, Mahalakshmi. So I'm not at all applying. Very good, Anjali. So I'm not at all applying any kind of force because how can you say that I'm not at all applying any kind of force? What's the conclusion? Like, how did you conclude that I didn't apply any kind of force? Because there is no form of interaction between me and that particular rectangular box, right? So in order for a force to happen or in order for a force to occur, there should be interaction between the two objects, which is very important. If there is no interaction between the objects, there will not be any form of force acting upon the object. Yeah, Sridhar. No, we just started the classes. We just started and we are actually discussing the chapter called force and laws of motion. Okay, so last class we have discussed what motion is, and today we are going to discuss force and laws of motion. Whoever is late, like we can actually like we are going to discuss today the second chapter of your textbook, which is force and laws of motion. Okay, yeah. So here we are actually here there is no form of interaction, and you said that there is no force acting between the object and me. So that is very important in terms of force because if the force need to occur or if you want to exert a force on any kind of object, there should be an interaction between the two objects. Based on that interaction, we can actually classify the force into different types that we will discuss later. So what can happen like when we are applying force? So here in this particular case, I told you like I have there is a rectangular block having a certain weight or certain mass, and I am standing next to it. And the second case, I am actually trying to push it away. I'm trying to move it. So it means that I am applying a force here, right? So in this case, I am applying a force here. And why do you say that I am applying a force here? Because there is actually interaction between me and this particular object. It means I am interacting with this particular rectangular block and I'm trying to move it. So what will happen as a result? And like when I'm pushing that box, what will happen? what is the end product? Like if I'm trying to move the box, obviously the box will start to move, right? The rectangular box will start to move. So you can actually see two things which a force can do to a body. Like force can change. The first thing is that force can actually change the state of rest or motion of an object. If the body is at already like initially the rectangular block was at rest, right? So then I tried to, and then I applied some form of force. I tried to move it by applying some form of effort. I put some effort, and it means that I actually put a little bit force on that object, and the body starts moving, which means that initially the body was at rest, and when I applied force, the body started moving. So that is one thing which force can do to a body. Like if the state of rest or state of motion can be changed when we are applying the force. So that is one consequence. Like that is one thing that force can do to a body. And the another thing, and the second thing is that force, when we apply force on some object, it can actually change the shape of an object. Okay, like let us say if you're having a like sponge or something, or a soft object like you have seen that yellow color ball which is made up of sponge, right? Like that smiley color ball that you have seen. I hope everyone has seen that. So when we are actually trying to fuse it, the shape changes, right? It means that you have that fusing action is actually a type of force, and it means that you have applied a force there, and what happened? And as a resultant of that, the shape of the object started to change, right? So this is another thing that force can do. Like when you are applying force on an object, two things can happen. One is the state of rest or motion can change, and the other thing is the shape of an object can be changed when we are applying a force. And another one example, can you say some example where we are actually applying a force and as a result and as a byproduct, the shape of an object is changing? Can you say any kind of example that you have seen in your daily day-to-day life where you apply in any object? Yeah, sponge is an example. Very good. And also like cutting of an object, you have seen that like chapati dough, very good. And you have seen like we can actually cut vegetables and we can cut different types of objects using knife or something sharp, right? So when we are actually cutting, what like that cutting is actually we are applying some force on that object, and due to that cutting force, the object is actually having a change of shape, right? So that is another one example that we can actually state where force is changing the shape of an object. And the first case, as we discussed, like force can actually change the state of rest or motion. So that for that you can, do you have any day-to-day like examples where you have seen where you apply some force so that the state of rest or motion of an object is changing? Like you might have played different kinds of sports, right? Cricket, football, etc. Like you might have played many different kinds of sports. So there, if you are kicking a football, the football initially will be at rest, which means the state of it's in a state of rest. And then when you are kicking the ball, it means that you are applying a force so that it starts moving. So that is one case where the state of rest is changing to state of motion. Or the opposite can also happen in a football game, right? The ball will be coming towards you, or the goal, you will be standing as a goalkeeper, and imagine that someone kicked the ball and it is coming towards you. So what will you do? Like you will try to stop the ball using your hand, right? It means that you are actually applying a force onto that ball with your hand. As a result, what happens? The ball, which was in a state of motion, the ball was already moving, like it was in a state of motion, and when you applied force, the ball came to rest. So there, what is happening? The state of motion is changing to state of rest. So these are two consequences two consequences that can happen when we apply force on an object. Yeah, it's also in cricket, not just in football. Like it's there in every kind of sport. You can actually see this form of interaction between objects. In a cricket, it will be the interaction between bat and ball. So you are actually, and force can also change the direction of an object. Okay, imagine in cricket, like the bowler will be bowling at you in a certain speed, right? So you are actually hitting the ball with the bat, so that what happens? The direction or the trajectory of the ball is changing. the direction of ball is changing because you applied a force. So force can do two things mainly. One is it can change the state of motion or rest, and then it can change the shape of an object as well. Okay. So now we are going to categorize this thing. We learned force, right? We actually explained what force is. Force is nothing. Is it force in a mirror? No, no. Like Nivedita asked, is it force in a mirror? No, like it's not force in a mirror or something. Force happens when you interact with another object. Like when not just you, when two bodies come in contact and when two bodies are in some form of interaction, then we can say that there is force applied between that object. Okay. And there should be, as a result of this, if there is no force, there won't be this end product. Then what is the end product? We said that when we apply force on something, the change of the body, there can be a change of shape or there can be a change in the state of rest or motion. So that in that way we can understand that okay, there is some force applied, or that's the reason why the shape got changed, or that is the reason why it started moving or why it came to rest. So means we cannot directly see how much force we are applying, right? But we can see the result and we can see the end product of what the force is. Like by the motion or by the change in shape, we can actually understand that okay, there have been a force applied between the body. Okay. So next we are going to categorize, like we are going to categorize this force into two types known as balanced and unbalanced force. So what can you say about balance? Like we have seen this. This is what is this game called? This game is called as a tug of war, right? So you might have seen this in Onam or anywhere where we are actually splitting into two teams and we will try to pull a rope so that how is the winning team decided? If one team on the other side, like if one team on let us say on the left side is pulling the right team towards them, then we can say that the left team has won. So this is the case where actually here, if you look at this particular race, we have mentioned that there are some like three people are pulling, right? Three people are pulling from both the ends. And one important thing is what is the unit of force? Unit of force is nothing but Newton, right? So we actually measure force with this certain unit called Newton, and it is abbreviated or the symbol of unit of force is capital letter N. So here we have two teams having three, symbol is capital letter N called Newton. So here we have two teams containing 3 persons each, right? So if you look at the first case scenario, 3 persons are there and you can see that there is a pulling force. They are actually trying to pull the object, right? So they are trying to pull the rope, which means they are trying to pull the other people, like other team towards their side. So if you look at the force that is applied, you can see that 300 Newton of force is being applied. Let us say each person is contributing 100 Newton each, 100, 100 and 100 Newton each. Okay. So the total for the force gets added up. That is another characteristic of force, because force, if you are applying multiple forces on an object, we can calculate the total force by just summing, like by just adding up all the forces, or maybe subtracting the forces. So that depends on the direction, whether if all the forces are acting in the same direction, you can actually add all the forces to get the resultant, to get the total amount of force. Okay. So if you see all these 3 persons are pulling in the same direction, right? It means that the force is applied in the same direction. So each person is applying a force of 100 Newton. So the total force will be 300 Newton, because all the 3 persons are pulling in the same direction. Means all the 3 persons are applying the force in the same direction. Therefore, we actually add up 100 Newton plus 100 Newton plus 100 Newton, which gives us 300 Newton total force. If the direction of the force is if the direction of the so if the direction of force, if one person here one person here. Now, if this green shirt guy was actually applying the force to the opposite direction, let's say just for example, okay, then the total force, what will be the total force? Let us just consider this left side team as of now. So I'm giving you a question where you can see that there are three persons, right? Two people are pulling towards the left side, and one person is actually pulling towards the right side with a force of 100 Newton. So what will be the total force? So what will be the total force acting? Yeah, very good, John. It's 200 Newton. So how do you got it as 200 Newton? Because two persons of 100 Newton each, these two persons are actually pulling in the same direction, right? This two person of 100 Newton. So it will be 200 Newton to the left side. And this green shirt person is actually applying the force on the opposite direction, which is 100 Newton. So since the forces are opposite, acting opposite to each other, the resultant force or the total force is how much? Total force is, we have to subtract the forces. So 200 minus 100, it is 100 Newton actually, okay? So this is how you can calculate. So you can actually, so the conclusion is that if multiple forces are acting on a body, you can calculate the amount of force acting on that body by either adding the forces or either subtracting the forces. Okay. So now let us go back to the case where we are actually discussing balanced and unbalanced force. So I want you to answer, like if in the first case, in the first picture, is it an balanced condition or an unbalanced condition? Like in the case where there are three persons each, is it a balanced or an unbalanced condition? Yeah, it's a and Deepak said it's a balanced condition. What about others? Like is it a balanced condition or it's an unbalanced condition? You can actually see there are three persons, right? Three persons per team pulling or towards pulling opposite to each other, right? So first case is a balanced, very good. So the reason why it is called a balanced condition is that the total amount of force is equal on both sides. That is why we are saying that the forces are balanced. So what will be the resultant? If the forces are balanced, in the first condition we said that the forces are balanced. Means this team is pulling towards the right side with a force of 300 Newton, and the other team is also pulling with a similar force of 300 Newton towards the left side. So you all said that these are balanced forces because in both the directions, similar forces are acting, right? Towards the left side also 300 Newton is acting. Towards the right side also 300 Newton is acting. So what will be the resultant? Who will be the winner in the first case? Which team is going to win in the first case? Yeah, very good, Nivedi. Then no one is going to win because there won't be any kind of movement. It will remain there only, like it will remain still because both the forces are equal. So there will not be any movement. Instead, the rope will remain at the same position only. But if this team, let us say this team is team A. If team A is applying more force, then there will be an unbalance, right? So in the second case, you can see that there is 3 versus 1. 3 people are there in one team, team A, and only one person is there in the second team. So obviously the forces, total forces, if we calculate, team A has a force of 300 Newton and team B has a force of 100 Newton, and team A is pulling to the left side and team B, the person is pulling towards the right side. So in this case, this is a case of an unbalanced forces because in both the direction, the forces, the value or the magnitude of the forces are different. So in the second case, obviously you can see that since 300 Newton is more than 100 Newton, the winner will be team A because the object or the rope will start moving in the direction of 300 Newton force, right? So from that you can actually conclude whenever there is an unbalanced force, there will be some form of movement or some form of motion happening. And the direction of motion, how can you say the direction of motion? the body will move in the direction in which force is higher. Okay, so force is higher, so in that direction the body will start moving. Okay, so here you can see that the team which is having a 300 Newton force is going to win because the rope will start moving towards their side, right? Force is higher, the motion will be on that side. If the forces are balanced, will there be motion? If the forces are balanced, will there be motion in between the objects? There won't be any motion. There will not, yeah, there will not be any motion if the forces are balanced. So in order to create a motion, or maybe in order to make something come to rest, we have to apply an unbalanced force. Okay, there should be a unbalance of forces so that then only we can say that there will be some form of action or resultant happening. And one another example I can state is that you might have, like you, everyone has gone to shop and all, right? So there, if you go to a shop and if you are asking for something, like if you are purchasing 1 kilogram of sugar, how do you know that it is 1 kilogram of sugar? Like they will be having one spring balance, right? They will be having one balance, old type of balance where in one pan you will be placing a weight, like you have seen that stone weight, right, of 1 kg, and in the other pan you will be starting to fill with sugar. Okay, so how can you understand that the sugar that you are adding is up to 1 kg is by the balancing of forces. So if this particular spring balance remains in a horizontal position, you can say that both the ends have the same weight. Like sugar will also be 1 kg, or this, and the weight will also be equal to 1 kg, so that it will remain horizontal. Okay. Or another example is that you might have seen seesaw in park, right? So if you and your friend went to a park and you have started playing in a seesaw, imagine that you and your friend is having same weight, like maybe 40 kilogram. You both are having 40 gram, and you both are sitting at the both ends of the seesaw. Okay. So will there be any motion? Like will it be stable? Will it remain horizontal, or will there be this particular rocking motion? What will happen if you are both having same weight? What will happen? What will be the resultant? Will you start rocking, or will you just stay stable in the horizontal position? Yeah, there will not be any motion because you two are having same weight, means both the forces acting by your weight, both the forces due to your weight are balanced. So there will not be any motion. But if at any case, if your friend is having maybe 50 kilogram, what will happen? This end will go down, right? Means whichever end is having more weight will go down, which means that there is an unbalance of forces, because you can clearly say that your weight and your friend's weight is not equal, and that is why the seesaw started rocking, right? So there should be an unbalance of forces in order for an object to move. Okay, or if your friend's weight is lesser than your weight, let us say for example, if it is 30 kg, what will happen? This side will go down, right? So whichever side, or whichever side has more force, or whichever side has larger magnitude of force, the motion will be towards that side only. Okay, so that is how we can actually state, like we can understand motion due to some form of forces. And uh, now we are going to discuss about external unbalanced force. In the last case, we saw that if the forces are balanced, an object will be at its like rusty position, or object will be at its equilibrium position. But if there is an unbalance of force, the object will start moving. Okay, so we need to consider unbalanced force in detail. So what do you mean by external unbalanced force? If you are having a, like let us say for example, you are actually staying inside a car. Okay, like let us say you are staying inside a car and you are trying to, let us say this is a car and you are inside your car. Okay, and you are trying to push the car from inside. You are trying to push the car from inside. So what will happen here? Like what will be the resultant? Like you got the situation, right? So I want you to imagine this situation. You are inside the car and you are trying to push the car from inside. So what will happen? It will shake. Like just ignore the shaking part or no, ignore the shaking part. What I'm asking is, will the car move or not? Because you are pushing the car from inside the car. It will not move. Very good. Yeah. But very good, Roshan. But I have to. And what about others? Like, can you imagine the scenario where you are inside the car and you are actually trying to push the car? Will the car move? Roshan said it will not move. What about others? Like, can you imagine? Will it move? Yeah, Lakshmi also said no. So, what is the reason? So, have you thought why that is happening? Why it is not moving? Anyway, you are applying some form of force inside the car also, right? So, why is it not moving? Yeah, very good, Alf. As Matthew said, yeah, because you are not applying the force from external sources. Yeah, means in this particular situation, you and car are part of the same system. Okay, so you are applying the force internally, which is not actually causing the car, which is not actually having any resultant or causing the car to move. The breaking of the car glass, Arjun said a good response, said it will break the glass, break the glass of the car. No, you don't need to push the car in the glass. You can actually push it in the seat or something. Okay. Okay. So here it is not moving because you are actually not applying the force externally. So if you want to move the car by pushing or by applying a force, you want to get out of the car and you want to start applying force or start pushing the car from the outside. Okay, then only the car will start moving. So in order for a motion to occur, there should be what external unbalanced force. What and why you can just state that you need an external force to move, but why are you specifying on this particular word called unbalanced force? Like in let us take the same example where you are actually standing outside. Okay, the car doesn't look like a car, right? Okay, so you are actually now you are standing outside the car and you are trying to push the car by applying some form of force. So why is this particular term unbalanced? This is an external force, right? Because you are actually applying the force outside the car and the car is our present system. So you are applying the force outside the car. Why is it external unbalanced force? Why is it called so? Because if you say that if the car is having a weight of, let us say for example it's a small car having a weight of 50 kilograms, or weight is actually denoted by Newton. So let us say that it is having a force of 50 Newton and you are also applying a force which is equivalent to 50 Newton. So will there be any motion? If you are applying the same force 50 Newton, drawing triangle. So if you are applying a same force of 50 Newton to the car and the weight of the car is also 50 Newton, so will there be any kind of motion happening? Even though this force is an external force, there will not be any motion, right? Because in this case, it's a balanced condition. Car is having a weight of 50 and you are also applying a weight of force of 50 Newton. So this is a balanced condition and hence it will not move. So in order for the car to move, you have to actually apply some more force than 50 Newton. You have to apply larger force, say for example, maybe 70 Newton or maybe 80 Newton force if you are applying, then the car will start moving. So that is why in order for motion to produce or motion to start, in order for a motion to start, you have to apply an external unbalanced force. It is very important. Okay, it's not just an external force. You also have to unbalance the forces so that there will be a motion in the object that you are applying forces. Okay, so is it clear? Yeah, and actually, water, like if it is 50 Newton, if the weight of the car is 50 Newton, even if you're applying 1 Newton extra, if you're applying just 51 Newton also, then also there will be an unbalance of force of 1 Newton, which can create a small motion. So if you increase the magnitude, like instead of 51 Newton, if you are increasing the magnitude to 60 Newton or maybe 70 Newton, what happens? The car will start moving fastly. Okay. So that, like, if that amount of force that you are applying actually result in the speed of motion. Okay. So this actually concludes to our first law of motion, which is stated by Newton, that can anyone say, like, can anyone explain, or can anyone just state first law of motion? It's actually very simple, right? So first law of motion is mainly concentrated on external forces acting on an object and the type of motion which the object is having. Okay, so this idea, the idea of external unbalanced force, will take us to the first law of motion, which states that every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of an external unbalanced force. So what does it mean simply? Like if one body is having in a state of motion, if one body is there, like one body is in a state of motion or maybe in a state of rest. So let us take the case, firstly let us take the case of state of rest. Okay. So imagine that if there is a football and this is your object. Okay. If there is a football and it's in a state of rest, means it's having no motion. So the state of rest will not change. When will it change? If you are actually applying an external unbalanced force, then the state of rest will change. Okay. Or Newton also mentioned that if one body is moving in a straight line, like if on some form of one rectangular block is moving in a straight line, and if you want to, it means that this rectangular block is in a state of motion. Okay. So if you want to change the state of motion into a state of rest, what you need to apply? You need to apply a force opposite to the direction of motion, and that force should be an unbalanced external force so that it will come to rest. Okay. So in order for you to change the state of rest or motion, you have to apply a force. So that is what first law of motion is about. Say that every object means until you are applying the force, like before applying, let us say in first case we said the football is there, which is at rest, right? So if you are not applying an external unbalanced force, it will remain at rest only. The body will stay there only. Or if some body is moving, actually here in our case, like if you roll a football, let us say that if you are rolling a football, it will not continuously keep on going, right? The reason is that there is a force of resistance acting opposite to it called as friction. So due to friction is an external force. Due to friction, the body will come to rest. Okay. And friction always acts opposite to the direction of motion, right? But imagine that if you went to space, you became an astronaut, and if you went to space, okay, and then very good, Lakshmi, for stating the first law of motion. And imagine that if you went to space, okay, in space you have a ball with you have football or you have a cricket ball with you actually throw it in one direction in space. So in space, there are no external forces acting on the body, and there is no friction because there is no a medium in space, and there will not be any kind of frictional resistance happening. So if you are throwing a ball in a straight line, the ball will keep on traveling towards, very far. So unless if we are able to, like if your friend is also there as an astronaut, and if he stops the ball, it will stop. Otherwise, it will keep on moving until and unless there should be an external unbalanced force acting on the ball to stop the ball. So this is what Newton's first law states. It states that any object which is in rest will remain at rest, or any object which is in motion will remain in motion, and it will only change when we are actually applying an external unbalanced force. Okay. So that is why the concept of external unbalanced force is very important while you are learning Newton's first law of motion. And here are two examples. Like here are two daily, like day to day. You have played caroms. Everyone has played caroms, right? So what happens? Like this is actually remaining. This set of coins which you have that remaining, right? This is in a state of trust. Okay, and this striker coin you are actually hitting. It means you are actually hitting means you are applying a force to the striker coin. So this striker coin was also initially a trust. When you strike the coin, you are applying a force. You are applying a force, and what will happen? According to Newton's first law, when you are applying an external unbalanced force, the body which is at rest will change into motion, right? So the striker coin starts moving because you apply an external unbalanced force, and the striker coin will hit the deck of coin that is arranged. So this deck of coin is initially at rest, right? So when the striker coins come and hit on it, what will happen? Force is being transferred to the deck of coin so that this thing will fall. Fall in the sense, why is it falling? Because this will start moving, and due to that unbalance, all the coins that are backed up will fall. So this is one application of Newton's first law. And we have seen, like, have you ever shaken a tree to pluck fruit from it? So when you shake the tree, why does fruit fall from the tree? What is the reason? And this is another example of Newton's first law of motion. Okay, this is also an application of Newton's first law of motion. And do you know how, when we are shaking, how does it fall? Because the tree and the fruit will be initially remaining at its rusty position, right? So when we are shaking the tree, only the tree will start shaking, but this fruit which will try to remain at rest, and that is why it is actually falling from the tree. Yeah, due to inertia, it will stay there. It will try to remain at rest, and that is the reason why when we are shaking the tree only the tree is moving. So what will happen is that particular fruit which is stationary there will crack and will fall down. Okay, so that is one another example, and these are called inertia. Inertia is the tendency. What do you mean by inertia? Inertia is the tendency of an object to remain in its particular state. Okay, and we have experienced this also, like when we are traveling in a bus, and if the bus suddenly comes to a stop, we all will move forward, right? So that is another reason, and that is also due to inertia, because we were actually, when the bus is moving, we are also moving. Last class we have said motion, right? So when the bus is in motion, we are also in motion in the same speed as that of bus. So when the bus suddenly stops, our body, which is inside the bus, will not suddenly stop at the bus. So what will happen? Our body will continue its motion, and that's why we always fall forward when the bus suddenly comes to a stop, because we were in a state of motion, and due to inertia, we actually continue to be in that state of motion. And after some time only, we will come to rest. And one another example that you can see everywhere is that you have seen ceiling fans, right? You have seen not just ceiling fan, table fan, everything. So when you switch off the fan, it will not immediately come to a rest, right? Due to inertia, it will start even after the current power supply is cut off. What will happen? Due to inertia, the blades of the fan will still keep on moving because it was in a state of motion, right? It was already in a state of motion. So it takes time, and there is this inertia, and inertia tries to resist the change. So the fan blades do not want to stop at that particular moment itself. So due to inertia, it will keep on moving for some little bit amount of time. Then after that only it will stop. Okay. So inertia is depending on mass. Inertia is the ability to resist the changes, and you can see that inertia of an object actually depends on mass. Okay, so if something is there, like how can you relate? How can you relate inertia and mass? We will discuss. Okay, so let us say that if there is I'm giving you two rectangular blocks of different weight. One is 5 Newton, and the second block B, is 10 Newton. Okay, so two rectangular blocks are there, which is at rest. Initially, it is at rest. And if I'm asking you to apply a force on this rectangular block, you will be applying a force. And I have a question for you, which is difficult to move. Like which need more force? Which need more force, or which block, like this 5 Newton block or 10 Newton block? Which block is more difficult for you to push or for you to apply a force and move forward? Yeah, Newton force. And what about others? Like which one is difficult to move? Is it 10 Newton force wala block or the 5 Newton force block? Which one is difficult to move? Obviously, it will be, yeah, very good, Teresa. It will be very good job. It will be 10 Newton force. Like why? Why? Because their inertia, as we discussed, inertia means it is the ability of a body to resist the change. If one body is at rest, it doesn't want to move. The body wants to remain there only. It's like a lazy, like if we are being lazy, we doesn't want to move from one place, right? We just want to sit or we just want to sleep. So it's like that. Inertia is like that. Inertia is a tendency for the body to not change its state of rest or motion. So initially these two blocks were at rest, right? So first case we have a block which is having weight of 5 Newton, which means the mass is less on this block, less mass. And second, the weight is more, so it means obviously the mass will be more. Okay. So in order for you to apply a force and in order for the block to move, you need to apply larger force on the 10 Newton block because it has more mass, it has more weight. So inertia of an object depends on the mass. If the mass of an object is actually higher, if the mass of an object is more, then the inertia will be more. Means there will be more resistance to change. Means this, what does it mean? Like you have to apply more amount of force in order for this body to move. Means in order for this body to change its inertia, you need to apply more amount of force. So inertia and mass are co-dependent. So whatever object which is having more mass will have more inertia. Okay. And you can, like another example that you can think about is if you are asking like another question or another example is that when you carry something, when you are having more weight, you need to, when you carry a luggage which is having more weight, you need to apply more force, right? So in that way, you can actually connect between inertia and mass. If I am saying that, how can you like, how is inertia and mass related to each other? You can say that both are directly proportional, or if the mass of an object is more, then obviously inertia will be more. Okay. Yeah, Nivedita, yeah, we will get to second law of motion in this particular class only. Okay, so at that time we can ask that out. So next is, this is another example that I have already mentioned about inertia of motion. Actually, we can classify inertia into two types. Inertia of thrust is there and inertia of motion is there. Okay. So the word inertia means the resistance to change. Okay. Inertia of motion. So inertia of thrust means an object which is already at rest will remain at rest, will have a tendency to remain at rest. And inertia of motion means an object which is already in motion will have a tendency to continue that motion. Okay. So here in this case, if the fan is actually rotating, if the blade is rotating, it is already in a state of motion, right? The blades are rotating. So even if you switch off the fan, it will have a tendency to continue its inertia of motion, and that is why even after switching off the fan, it keeps on rotating for some amount of time. Okay. And inertia of thrust, like this is a case where you can actually see inertia of, this is also inertia of motion. Inertia of thrust, this is a case where you can see inertia of rest because already the fruit were at rest, so it actually has a tendency to remain at rest for some more time. Okay. So these are two forms of inertia, inertia of thrust and inertia of mass. You can expect questions like, like you can expect this similar kind of question where they will be asking, what will happen? Like, what will happen if you just shut down the power of a fan? What kind of inertia is it? Is it inertia of motion or is it inertia of thrust? So you know that if how you can analyze is that if one body is already in motion, then you can understand that there will be inertia of motion there. And if one body was already at rest and we applied a force so that it start moving, so there it is a case of inertia of thrust. So you have to understand the situation before the force was applied. Okay. So now we are going on to another term called momentum. So momentum is a characteristic of objects which is in motion. So it's a characteristic property of moving objects. So objects which are in motion have this particular characteristic called as momentum. So what is momentum? You all know momentum is described, momentum is mentioned by letter P, and momentum is the product of mass of the body times the velocity in which the body is moving. Okay. So I have a question. What is the momentum of an object? If I am having a vehicle which is having 200 kilogram, I am having a bike which is weighing 200 kilogram, and the bike is at rest. Bike is at rest. So what will be the momentum of the bike? Yeah, what will be the momentum? It is, yeah, you guys said it is zero. Why is it zero? Because momentum is a characteristic which is only for an object which is at motion. Okay. If one body is at rest, you cannot say that that body has momentum. No, you can only say one body has momentum when the object starts moving. Okay. And what is the momentum is, it's a vector quantity experience, and momentum will be experienced in the direction of velocity. Okay. In whichever direction it is moving, that direction only momentum will occur. And I have another question for you. Yeah, 200 into 0 equal to 0. What is the unit of momentum? Can anyone say the unit of momentum? We know that momentum P is mass times velocity, right? So what is the unit of momentum? It will be mass is, yeah, very good, kilogram meter per second. Yeah, because mass is kilogram and velocity, unit of velocity is meter. Yeah, so momentum, the unit of momentum is kilogram meter per second. So does the body at rest has momentum? Does the body at rest has momentum or not? What will be the answer? Momentum. No. Yeah, very good. So whichever body is at rest will not have momentum, because momentum is a characteristic of a moving body. So that you have to always keep in your mind, that momentum, only object which is having motion will have momentum. And this idea of momentum, if you say, I'm asking, like, you can expect one type of question where I'm having a train. There is a train which is having a mass of say 1000 kilograms, and there is a car which is having a mass of 200 kilograms. And both these vehicles, both the train and the car, is moving at the same velocity. Okay. So which will be having more momentum? Same velocity. So which case will have more momentum? So that kind of question you can expect. In this particular case, which object, which body, or which vehicle has more momentum? Yeah, John said the train has more momentum. What about others? Like, which body will be having more momentum? Obviously, if two bodies are there, and if two bodies are in motion with the same velocity, then the object which is having higher mass will have more momentum. Okay, so from momentum we can actually go to the second, like the momentum. The idea of momentum gives us the definition of second law of motion stated by Newton, which is known as Newton's second law of motion. So what does it state? Newton's second law of motion states that the rate of change of momentum of a body is directly proportional to the unbalanced external force acting on it. So what does this mean? Like, what does this sentence mean? This is the statement given. It states that the rate of change of momentum is directly proportional to the unbalanced force acting on it. So let us take one example. I am stating you one example. There is this, there is one football. Like two types of football I am giving to you. Let us say one simple example where you can actually imagine. Okay, two types of football are there. One football has more mass. One football has a mass of 10 kg. And another football has a mass of 5 kg. Okay. So, and and I am there. I kick the football with the same force. So the football started moving in the same velocity. Let us say you are standing here as a goalkeeper. Okay. So the first football of 10 kilograms is coming towards you at a velocity of 10 meters per second. So what will you be doing? Like you are a goalkeeper, right? So you'll be catching the ball or you'll be stopping the ball. So and the second case also 5 kilogram ball is traveling towards you at 10 meters per second, and you are still there trying to catch the ball. In this case, you will apply more force. This case will be applying more force in order to stop the football. Yeah, John said the first case, and what about the others? Like which case may you have to apply stronger force in order to stop the ball? Yeah, John, very good, John, and we can wait for others' response also. So you guys are the goalkeeper. Okay, so you have to stop the ball by applying a force into it. That you know. So there are two balls which are having different masses. One is 10 kilogram mass and the other one is 5 kilogram mass. And the balls are coming in towards you in the same velocity. Velocity is not changing. You are having the same velocity. So you have to apply force. And I am asking you which case you have to apply more force. Yeah, very good, Lakshmi. You have to apply the 10 kilogram. In order to stop the 10 kilogram ball, you have to apply more force. The first one. And why is it so? Is it just because the mass is more, or is it because of the momentum? It is because the first case, in the first case, what is the momentum? Let us calculate the momentum. We know that momentum P is equal to mass times velocity, right? So first case, let us say P1, the mass is 10 kilogram and the velocity is also 10 meters per second. So the momentum is 100 kilogram meter per second, right? And in the second case, what is the momentum? P2, it is 5 kilogram mass is there and the velocity is same 10 meter per second. So the momentum is 50 kilogram meter per second, right? So since the momentum is more, you need to apply more force. In order to stop this first case ball, you need to apply more force. So that is what second law is all about. Means if the momentum, the rate of change of momentum is directly proportional to the force. If the momentum is lesser, it means that you have to apply less amount of force in order to stop an object. Okay, so that is how momentum and force is related by the second law of motion. Okay, yeah. And now we are going to like mathematically prove how this is true. Like we said that second law states that the rate of change of momentum is directly proportional to the unbalanced force acting on it. So now we will define, like we will mathematically come to a conclusion how we can find the force of acting on an object. Okay. So mathematical formulation. We know that what's the rule? The rule states that force is directly proportional to rate of change of momentum. So rate of change of momentum means change in momentum, right? Let us say P1 minus P2 as the change in momentum. So if you are having one object, one body is there, having a mass m, and the velocity is changing. Initially, it changes from v1 to v2. The velocity is changing means the momentum will be changing. If mass is if I am running, like initially I am having a weight of let us say 60 kg or 50 kg. So I am running. I am having a weight of 60 kg and then I started running. So if I am increasing the velocity, it means that my momentum is also changing, right? Because momentum is a product of mass and velocity. So I am increasing the speed means my momentum is changing. So let us assume a body having a mass m, having a velocity change v1 to v2. It is changing from v1 to v2. V2 is more, okay? So that we can say that force directly proportional to momentum is initial momentum is mv1 minus final momentum will be mv2. Okay, so we can take this thing as m as constant, m as common, and v1 minus v2. And there is another thing called rate of change of momentum. Force is not just proportional to change in momentum, but it is proportional to rate of change of momentum. So rate of change, yesterday when we discussed the motion, we have said rate of change of motion, rate of change of velocity, rate of change of displacement. So rate of change means something changing with respect to time, right? So this is dt something with respect to change with respect to time. So this will be rate of change of momentum means the momentum is changing with respect to time means divided by time. So we can say that is directly proportional to m into, we can write this as v1 minus v2 by t. So what is this particular quantity? This is rate of change of velocity, right? Velocity is changing with respect to what? Just changing of velocity. Velocity is changing with respect to time. So you all know, like yesterday only, not yesterday, the last class only. Yeah, very good, Lakshmi. Like we have discussed rate of change of velocity is nothing but acceleration. So S directly proportional to mass times acceleration, because this is rate of change of velocity, which is acceleration. So we can say that F equal to, in order to remain the proportionality, we will multiply by a constant called as K, and the value of K will be 1, so that we will get force as force acting on an object as mass times acceleration. So this is the mathematical formulation of Newton's second law of motion, because we actually stated this from the very beginning, very initial part of the law, which states that force is directly proportional to rate of change of momentum. Okay, is it clear? Yeah. So force is directly proportional to rate of change of momentum, and we can conclude that force acting on an object having a mass is equal to force is mass times acceleration. Okay. Okay. So this derivation is very much important, because they can ask this derivation, like they can ask you to mathematically formulate the Newton's second law of motion. So this derivation is important. So in order to derive something, you should know the basics. Like you should know what the law is stating. So from the law itself, we can actually derive by our own, and you have to do more practice on this particular derivation part. Okay. It's actually simple, because if you are knowing the law, if you are knowing the Newton's second law, then we can only derive the mathematical formulation of this Newton's second law. Okay, so the important part is understanding what the law is mentioning. The law means that if there is more change in momentum, if the momentum change in momentum is more, it means that the force applied, or for the force acting will be more. Okay. Now we will come to the last and final part of this particular chapter, called as Newton's third law of motion. This is very simple. Like the statement compared to the first law and second law, the statement of Newton's third law of motion is very simple, but you have to understand what this law is about. Okay, so it states that Newton's third law of motion states that to every action there is an equal and opposite reaction. So this is the statement of this particular law. So what does it mean? Yeah, action and reaction are nothing but forces only. Very good. So what does this particular third law mean? Means if you are actually applying a force onto one object, we said that force is the interaction between two objects, right? There is one object, and if there is another object, force means the interaction between these two objects, which will result in a change of state, or change of state of rest or motion, or change of shape. So what does third law state that? So let us discuss third law with an example. Imagine that you are having, imagine that there is a wall, and you are standing in a roller skater. Okay. You are standing in a roller skater, and the roller skater is actually still, and imagine that you are trying to push the wall with your hand on top of the roller skater. So what will happen? Means what is happening here is you are actually applying an action force, or you are applying an action force towards the wall. So what will be the resultant? What will happen when you are actually pushing, when we are actually pushing a wall standing on top of a roller coaster? What is the resultant? What will happen here? Okay, can anyone say what will happen here? Yeah, it's very easy, right? You will start moving backward. Like when you are standing on a roller coaster or anything, any rolling surface, and you are pushing the wall, there is this wall. You can actually try this at your home, okay, but be very careful. When you are pushing the wall means you are actually applying an action force to the wall. So according to Newton's third law, the wall is also pushing you back. Okay. And that is why you are actually moving backwards in the roller skater. Means you will be moving backwards in the roller skater because in order for motion to occur, there should be some force applied, right? If there is no force, if the wall is not applying any force, then you will not move. You will just stand there and you will keep on pushing the wall. Okay, so the reason why you are moving is that the wall is actually applying a similar force opposite to the direction of the force that you are applying, called as reaction force, and that is why you are actually moving. So there are cases like, let us say, uh, we actually mentioned the example of pushing a block, pushing a rectangular block or something, so that it will start moving. So you can imagine, you can think, or you can ask that why is this block pushing, like according to Newton's third law, if we are pushing the block should also push us, right? And we should start moving backwards, right? The reason why we are not moving backward is the magnitude of interaction is lesser. Okay, so that's why we are not moving backwards. And only the particular rectangular block is moving, but it doesn't mean that there is no reaction force from the block towards us. There is reaction force acting from the block towards us, but like our magnitude or the box will be small, and that is the reason we are not moving. We are actually not moving backwards because of the magnitude of our weight actually. Okay. So actually, on another example, like Roshan said that shooting a gun and it jerks backwards. That is another example of Newton's third law of motion, because uh, the recoil of gun is an example of Newton's third law. There is also an action force, and due to the reaction force, the gun will move a little backwards, or gun will jerk backwards, which is an application of Newton's third law of motion. Okay. So this is recoil of a gun is an application of what? Newton's third law. Okay. So what does it mean? It means that whenever you are applying a force, and in this particular case, you can actually when we paddle a boat or when we are rowing a boat, the reason why the boat is moving forward is when we are paddling means we are applying a force. So there is a reaction force from the water to the boat in the opposite direction, and that is the reason the boat starts moving forward. So always there will be the forces are acting as a couple. Like there will be an action force and resultant there will be a reaction force also. Okay, so that is what Newton says. Means forces always act on a couple. If you are applying a force of what, or 50 Newton towards the wall will start applying 50 Newton backwards because force come in pairs. Okay, that is the idea of Newton's third law of motion. Okay, so now what will we do? Like we will actually we have now discussed three laws of motion, which is Newton's first law of motion was there, and then we discussed second law of motion. Before going into second law of motion, we discussed what momentum is, right? Now we will just solve some examples that you can expect. We'll solve some questions that you can expect in the exam. So we'll start solving. Like there is a constant force acting on a body having a mass of 5 kilograms for 2 seconds. So what is we have a body having a mass, and what is the mass? You can also do at the same time with me, okay, so that you get practice. The mass of the body is 5 kilograms, and the force is acting. There we are applying a force on an object having a mass 5 kilograms for 2 seconds. So the time here is time t, in which the force is acting is 2 seconds. So while we are applying the force, the change that is happening is the velocity of the body, or the state of motion is changing here. You can see that the velocity of the body is increased from 10 meters per second to how much? Sorry, 5 meters per second to 10 meters per second. Okay. So here, due to the action of force, we can see that the state of motion is changing, in which in turn its velocity is actually changing. So what is the magnitude of the force? So how much force we applied in order for this particular body to change its velocity from 5 meter per second to 10 meter per second. That is what it is asked, right? So we have to find out the acceleration. We know that according to second law, force is nothing but mass times acceleration, right? So we have to find the acceleration here. So how will we find the acceleration? We know that there there is a change in velocity. Already there is a change happened in velocity. So we know yesterday only we learned, not yesterday, in the previous class we learned about acceleration as the rate of change of velocity. So there is a change in velocity, which is v2 minus v1. Acceleration is v2 minus v1 divided by the time taken for this particular change to happen. So what will be the acceleration? It is very easy. It is 10 minus 5 and the time is 2 seconds. So 5 by 2. What is the answer? The acceleration we got here is 2.5 meter per second square. So when there is a change in velocity, it means that the body started accelerating, right? So acceleration is 2 point. Now we have the mass also. Now it's easy to calculate the force because we already calculated the acceleration. Now the force will be mass times acceleration, which is mass is 5 kilograms into how much is the acceleration? 2.5 meter per second square. So what will be the answer? 5 into 2.5, how much will it be? Yeah. Okay, we can actually calculate. You understood the idea, right? So the magnitude only Frida and Sharma. What about others? Like you got the idea of calculating the forces, right? So the force here is 12.5. Unit is Newton. And last class also I have mentioned you have to mention the unit, or otherwise if you are just mentioning the magnitude, then we cannot understand what the quantity is. 12.5 is just simply just a number, right? So we have to always write the unit along with the number in order to convey what we are actually telling. Means 12.5 is number. So if it is along with Newton, if we are adding the unit Newton to it, we can understand that okay, 12.5 is the magnitude of force. Or instead, if you are adding, instead of Newton, if you are adding some other unit, maybe meter means, okay, 12.5 is the, like is the length measure or something, okay? Very good, John. So this is how you calculate the force according to the second. This is the, this kind of question is from second law of motion. So here actually, if you look into the question, you can see that, and according to second law, we know that force is mass times acceleration, but here acceleration is not given. We have to find out the acceleration through the data which is given, which is the change in velocity. Okay, so from the change in velocity, we can actually calculate the acceleration like we discussed in last class. Okay, now we will solve one more question. Which of the following conditions require greater force? So we know that we discussed second law, right? So second law states that a body which is having more change in momentum will have more force applied, right? Okay, so first case is a body is there having a mass of M1 is mass of 5 kilograms. It is accelerating at the rate of how much? 5 meter per second square. And second case is that the body is having a mass of 3 kilograms. It is accelerating at the rate of how much? It is accelerating at the rate of 10 meter per second square. So which body will be having, like which condition require more force? Yeah, so we have to calculate second case. Very good, Sriraj and John. So we have to calculate the force acting here by the help of second law of Newton's second law. Force is mass times. So we can say that F1 is the force acting on the first case, which is 5 into 5 meter per second square, which is 25 Newton, right? And in the second case, you can see that it is 3 into 10 is 30 Newton. So it is very clear that the second case is having, second case require greater force. In order to stop or in order to continue the motion, we need to apply more force on the second case. Okay, so second case needs more force. Okay, so this is also one another type of question that you can expect in your exam regarding the Newton's second law of motion. Okay, so now we will just summarize what we have learned so far. Okay, so initially what we told was we discussed about what force is, right? So in order for a force to occur, there should be an interaction between two objects, then only we can say that there happened a force. So we actually discussed about force initially, and also we discussed about the two kind of force known as unbalanced and balanced force. So in order for an object to move, if an object, we want to move an object, there should be an unbalanced external force. Okay. Then from the idea of force, we came into inertia. Inertia means the resistance to change, right? And from inertia, we actually directed to the very first law called as Newton's first law of motion. Which, what is Newton? It says that a body, whatever state it is, like whatever state the body is, it will try to remain in that state only unless we are applying an external force onto it. Newton's first law, and then we came to the concept called as momentum. Momentum is the characteristic of a body which is in motion. Okay, so a body which is moving has a particular characteristic called as momentum. And then from momentum, very good, Lakshmi. Then from momentum, we actually came directly to Newton's second law of motion, which says that rate of change of momentum is directly proportional to the force applied. And then lastly, we have discussed Newton's third law of motion, right? And we have action and reaction forces, and how action and reaction forces occur in a pair. So from that, we actually came to the conclusion of Newton's third law, right? So these are the main things. Like you should be able to like whenever you're learning physics, don't just mug it up or don't just by heart the statement. There will be questions asked as define Newton's second law, define Newton's first law, but you should not just by heart the sentence or by heart the statement. Instead, you should be able to understand what it really means. So if you are able to study in that manner, then you will not forget actually. You will understand. If you are having the idea of Newton's second law means there is the relation between momentum and force, then you can actually you will not forget while writing on the exams and all. Okay, that is one way to learn physics, that you have to understand and learn. Okay, so if you're having any doubt, you can actually ask. Like you can just raise your hand or you can type in the chat box as well. We have one more class to go. Also, like in the next class, we will be discussing about gravitation, the chapter called gravitation. Okay, so in the next class also, if you are having while you are revising the previous chapter motion, and today's chapter was force and laws of motion. So while you are revising the chapters, and if you are getting stuck at any point or any concept, or even when you are trying to solve some problems and getting stuck, you can ask on the next class, where it will be the last revision class of this particular term. Okay. Okay then. So if you are having no doubt, like you can wind up the class. So we'll see you next class, which will be the last session of this particular revision class. Okay. Bye then.